All right, welcome back. Today in Algebra A, we are going to talk about section 4.4, which is solving systems of equations with word problems. So we're going to use the same methods we've been using, substitution, elimination, only now we've got to set our equations up in the context of a word problem. So this first one starts out here with biology. You're talking about looking at alligators here over a period of 12 months, and the first alligator weighed 4 pounds at birth and grew by 1.5 pounds per month. The second one weighed 6 pounds at birth and grew at 1 pound per month, and they want to know when will they weigh the same. So if we let X be our months and Y be the weights, here's our equations for our two alligators. So alligator 1, 4 pounds plus 1.5 pounds per month. Alligator 2, 6 pounds plus 1 pound per month. Since both of them equal Y, we can set them equal to each other. So basically we're using substitution here. So I put 4 plus 1.5x in right there for Y. We'll subtract x from both sides. Then we can subtract 4. So I get 0.5x equal to 2 and divide. And what we find out is those two alligators will weigh the same after 4 months. Now they didn't ask us to find the weights. We didn't have to plug it back in and find Y at this point. They just want to know how many months before they weigh the same. But in our problems that will follow, we will solve for both variables. So we could plug this back in. If we did, we'd figure out that they both weighed 10 pounds. All right, as you drive around your car with your parents, you probably have XM or Sirius or some form of satellite radio, possibly at home or in the car. And so they have a monthly fee and you have your cost. So one service is $10 a month plus an activation fee of $20. And the other one is $11 a month and a $15 activation fee. Now, I'll be honest, nobody's paying $10 or $11 per month, but for setting up this problem, that's just the numbers we used. So again, since both of these equations are equal to Y, we can put the 10x plus 20 right there, and we're going to solve for x. So we'll move the smaller one, subtract 10x. Then we subtract 15, and x is 5 months. So again, it says for what number of months is the cost the same? 5 months is when it'll be the same. They did not ask us to find that cost, but we could if we wanted to. At the end of 5 months, you would have spent a total of $70 with both services. But again, they just wanted the number of months for when the cost was the same. All right, if you've seen Billy Madison, you'll like this one here. So we got our snack bar here selling snack packs. So the large one's $5, the small one is $3, and in one day they sold 60 of them for a total of $220. So we'll let X be the large snack pack, Y be the small one. We know that we sold a total of 60 of them, and when we get into the cost, $5 for the big one, $3 for the little one, total of $220. So now I've got my two equations. You can do substitution or elimination. I'm going to do elimination, so I'm going to multiply this one by 3. And I get this result over here. So I just took the bottom equation, moved it over, multiplied the top one by 3. And now we can subtract those Y values. And so when we do that, negative 2x equal to negative 40, and we'll divide. So they sold 20 large snack packs. Plug 20 back into this equation, and we solve for Y. We get 40 of the small snack packs. So 20 and 40 is our answer. And again, in this case, they did want both answers. Okay, renting movies and video games. I know a lot of people now have Hulu or Netflix and stuff, so basically you're just streaming online at home. But back in the day, you could rent video games for your game system or DVDs. I know some people still do that. But so it says I paid $22, and that's to rent the movies and video games. $4 per movie, 2 per game, and rented a total of 6 items. So we'll let X be the movies and Y be the video games. We rented a total of 6 of them. So x plus y has to be 6. It was $4 per movie, $2 for video game, total of $22. Again, you could use substitution, but I'm going to multiply the top one by 2. So that gives me this result here. And now the y values are the same in the two equations, so I'm going to subtract again. Negative 2x equal to negative 10. We divide, and we get 5 movies. And if we have 6 total, and we got 5 movies, then we have to have 1 video game. So again, you could have solved this for x or y and plugged it in. I think it's easier to do elimination, so that's why I multiplied. And then we can solve for x and then plug it in for y. All right, Jill and Greg, they went to the movies. Jill purchased 2 pretzels and a soda for $11.50. Greg bought 3 pretzels and 3 sodas for $21.75. So apparently Greg was hungry and thirsty and has a lot of money to spend. So we'll let X be the pretzels and Y be the sodas. So Jill had 2 pretzels, 1 soda for $11.50. Greg, you can see here, had 3 and 3 for $21.75. I'm going to multiply this top equation by 3. That'll cancel out the y's here. So I multiply the top one, get this result. You can see they both have 3 y's now. So we'll subtract. And 3x equals 1275. So when we divide, x is 425. Now that we have x, we can plug that back in. You can use either equation. I plugged it into the top one. I did that because you have 1 y here, so we won't have to divide. So 2 times 425 is 850. Subtract the 850, and it's $3 per soda. So $4.25 for a pretzel, $3 for a soda. I'm assuming that's a small one. And for some reason, you don't have refills at this particular theater, but there's your price for the pretzel and the soda. And one final example, and we'll be done with our notes for today. And this notes video you can use for this entire section, so it'll be good for our worksheet today and our worksheet later in the week. All right, Lucy found an envelope. It's got $2 bills in it and $5 bills for a total of 46. And the number of $2 bills is 5 more than twice the number of $5 bills. All right, that one's harder to set up, but we'll deal with the cost here first. So we'll let X be $2 bills, Y will be the $5 bills. So $2 for every one of these, 5 for every one of these, for a total of $46. So that's really, of the two, that's the easier equation to set up. This one's a little harder. The number of $2 bills, so that's X, so X equals 5 more, so we're going to add 5 to twice the number of $5 bills, and that's Y. So 5 plus 2Y is equal to X. This is already solved for X, so we're going to go ahead and plug this number in right there for X. We're going to use substitution since it's already set up that way. So we plug the 5 plus 2y in here. We'll distribute. 2 times 5 is 10. 2 times 2y is 4y. I'll combine my y terms here. So I get 10 plus 9y. Subtract 10. And divide, and we get 4 $5 bills. Now I can plug that into either one of these equations. This one's going to be easier because it's already solved for x. So we'll plug 4 in here. 2 times 4 is 8. So x is 13. So we have 13 $2 bills and 4 $5 bills for a total of $46. All right, that concludes your notes today for section 4.4. Got any questions, go ahead and shoot me an email or a Google Hangout request, and we'll help you out. All right, thanks a lot.